Hello and welcome to the video on angle relationships. By the end of this video, you should be able to identify the different sets of angles and differentiate them from each other. Our first type of angle set are adjacent angles. When I hear the word adjacent, I think of right next to, and that's exactly what adjacent angles are. They're angles that are right next to each other. Let me draw a picture. Here we have an example of adjacent angles. In this picture, angle 1 and angle 2 are adjacent to each other. They are adjacent for three reasons. These are the three criteria you need to check to make sure something is adjacent. First of all, they have a common vertex. You'll note that angle 1 and angle 2 both have a vertex of B. The second thing they have to have is a common side. In this picture, ray BD is the side of both angle 1 and angle 2. The third thing they have to have is no common interior points. What I mean by that is any point that is in angle 1, for example point E, is not also inside of angle 2. And a point inside angle 2, for example point F, is not also inside angle 1. They are mutually exclusive. There's no point that's in both angles. These next three pictures are examples of things that are not adjacent angles. Some of the criteria are going to be met, but not all three. The reason why our first example with angles 3 and angle 4 are not adjacent is because they do not have a common vertex. Angles 3's vertex and angles 4 vertex are at different spots. The other two criteria here are being met. They do have a common side and they have no common interior points. But because all three criteria weren't met, they are not adjacent angles. The second one, angles 5 and angle 6, are also non-adjacent. They have a common vertex and no common interior points. However, they do not have a common side. And the last one, angle XYZ, which is our biggest angle here, and the smaller angle 7 are non-adjacent as well, because even though they have a common vertex and a common side, they do have common interior points. For example, point W here is in both angle XYZ and angle 7, therefore it is also non-adjacent. We can use our understanding of adjacent angles to help us understand what a linear pair is. A linear pair is two adjacent angles whose non-common sides are opposite rays. If you remember what opposite rays are, those are rays that have a common vertex and together form a straight line. For example, rays XY and XZ. To make two angles here, I would need another ray which creates two angles. Angles 1 and 2 in this example are a linear pair. They are adjacent to each other because they have a common vertex and a common side with no common interior points, and their non-common sides are opposite rays. Our next set of angles are vertical angles. Vertical angles are two non-adjacent angles formed by intersecting lines. So if I draw two intersecting lines, I create two sets of angles. The vertical angles here are the ones that are non-adjacent. For example, angle 1 and angle 3 form a set of vertical angles, as do angles 2 and angle 4. Another relationship between two angles are complementary angles. Complementary angles are angles that have a sum of 90 degrees. My first picture is a set of complementary angles that are adjacent to each other. In this case, angles 1 and angle 2 do add up to 90 degrees. This second set of angles is also a set of complementary angles. This set of complementaries, though, are non-adjacent. They don't have a common vertex and side. Supplementary angles are two angles that have a sum of 180 degrees. Like complementary angles, these could be adjacent or non-adjacent. An example of a set of adjacent supplementary angles would be a linear pair. Two angles that have non-common sides that are opposite rays would be supplementary. Since they make the straight line, angles 1 and 2 would have to add up to 180. You could also have a set of angles that are non-adjacent and supplementary. For example, angles X and Y here would add up to 180. They're also supplementary. And one last term for us, two lines are perpendicular if they intersect to form a right angle. So for example, line L and line M are perpendicular to each other. They intersect each other. At the intersection, they've created four right angles here. All four of these angles are 90 degrees, so those lines are perpendicular. One more notational thing here for perpendicular lines. When two lines are perpendicular, they'll use a special symbol for that. They'll say that line L is perpendicular to line M. So that symbol right there means perpendicular. Whenever you see that, you need to be able to recognize that and know that those two lines would then intersect to form a right angle. So let's try a few examples. Example number 1, refer to the figure at the right and name an angle pair that satisfies the following conditions. Part A, name 2 obtuse vertical angles. There's a few terms that we need to remember there. First one is obtuse. Remember obtuse, that meant that it was more than 90 degrees. And vertical angle. Those were our angles that were created by 2 intersecting lines that were non-adjacent to each other. If I look for 2 intersecting lines here, I see a couple different sets. Let's look at line AH and line BF. There's a few different angle sets here. Angle 1 and angle 4 would be vertical angles, as would angle AGF and angle BGH. We want the ones that are obtuse, meaning they're over 90 degrees. Well, that would be our second set there, angles AGF and angle BGH. Part B, name 2 acute adjacent angles. Again, we need to know what 2 words mean there. Acute meant that they are less than 90 degrees, and adjacent meaning they share a vertex and a common side. I have a few choices here. I'm going to choose angle 1 and angle 2. They are both acute, meaning they're both less than 90 degrees, and they are adjacent to each other. They have a common vertex G and a common side BG, with no common interior points. Part C, name 2 angles that form a linear pair. Remember, a linear pair was 2 supplementary angles whose non-common sides were opposite rays. So I'm going to look for my straight line again here. I'll use that one. I had other choices, but I'll choose line AH or AD. From here, I just need to have 2 angles there. So I'll pick another ray. We'll use that one right there. And we'll say that angle 1 and angle BGH would be our linear pair. There's many other choices in this picture. This is just the ones I chose. And part D, name 2 acute vertical angles. Back to our 2 vertical angles, which were created by intersecting lines. The 2 acute ones were angle 1 and angle 4. Let's move on. Example number 2. Find the measures of 2 supplementary angles if the measures of one of those angles is 6 less than 5 times the measure of the other angle. For this type of problem, I would suggest always drawing a picture. I know I have 2 supplementary angles. I'm going to draw them as adjacent supplementary angles, or a linear pair. I know that one of these angles is 6 less than 5 times the measure of the other one. Well, I don't know how big either one is. So when I don't know how big something is, I'm going to assign it a variable. Let me choose x. If I choose the smaller angle here to be x, the other one would be 6 less than 5 times that. Well, 5 times something would be 5x. 6 less than that would be minus 6. I now know that both these angles, since they are supplementary, have to add up to 180. So I'm going to add these together and solve for x. When I add them together, I need to combine like terms. 5x plus x was 6x. Now that I've combined my like terms, I can solve this equation by adding 6 to both sides. When I add 6 to both sides, I get 6x is 186. And when I solve for x, I divide by 6 to get x is 31. We read the problem carefully. It says find the measure of the supplementary angles, which means I'm going to have to plug these back in. If x is 31, this angle here would be 31 degrees. And 5 31s minus 6 would wind up being 155 minus 6, which is 149 degrees. To double check, those 2 angles should have added up to 180 because we said they were supplementary. 149 plus 31 does indeed equal 180. So we know we got it right. And one last example, example number 3. Use the figure at the right to find out what x and y are so that BD is perpendicular. Remember earlier we said that that symbol right there means perpendicular to FC. Well, if FC and BD have to be perpendicular, that means they have to intersect to form a right angle. So this angle here is going to be a 90-degree angle, and these 2 here together, we're going to have to be a right angle. To figure out what x and y are, let's start with x. My 3x plus 6 and 9x would have to add up to 90 degrees. When I combine my like terms, I get 12x plus 6 equals 90. And then to solve for x, I'll subtract 6 and then divide by 12. 84 divided by 12 is 7. Now we know x. Let's move on to y. We look back at the picture, angle BAC is 3y plus 6. Well, for those lines being perpendicular, that has to be a right angle. So I'm going to set the 3y plus 6 equal to 90. And again, I just need to solve for y. Subtract the 6 to get 3y is 84, and then divide by 3 to get y is 28. So to finish off our problem here, x turned out to be 7, y turned out to be 28, and we are done.